Come on. You can do
I
it.
did lessons.
Good morning, everybody. Welcome to those of you who are watching live. Hello to my my live watchers. We're going to go over the practice test, so please have that out. Please have out the question sheet also. Please be in dress code. Please be in dress code.
Jack, what are these? I thought you were able to take it off.
No, it's not just for show. It's a garment, it's a piece of clothing. Please wear it. What was that? Oh yeah, you can use the chat if you want to ask questions. But first I'm going to read off the answers to the test questions. Good morning.
If I were to wear a suit of armor,
And then we'll go over any of these and start lesson 5. Just have out the practice test, please, and the sheet so we can go over that. What?
I'm not a textbook.
You didn't get one yet?
No, he didn't give me one.
Okay, I'll give you one today.
bro,
Okay.
that's what you asked.
Good morning. As a reminder, this class begins at what time? What time?
8:40.
8:40. You need to be here on time. Our time is very precious. Okay, so 1A, 180 degrees. Please check your work as we go along. Make notes of ones that you got wrong so that you can ask about them or go back to them later. 1A is 180 degrees. B is 90 degrees. 2A, a triangle which has 3 angles that measure less than 90 degrees. 2B, a triangle where 2 sides are of equal length. 3, parallelogram. 4, equilateral. 5, 90 degrees or right angle. 6, 14 pi inches. The practice test? Thing from yesterday?
Yeah.
Wait, what's number 4 again?
Those are the, okay, do you have the sheet also? That you can. No.
What's
So it should be,
I think I know what
it's this one.
What's 5 and 4?
Which one's
Yeah, I know that.
This one's what?
4 again?
This one?
Equilateral. Yes, that.
What's 5?
90 degrees or right angle. And those are the questions on that one?
So these
Yeah,
guys.
all right. Good, yeah, go through and check your answers along with us. 6 is 14 pi inches. 7 is 16 pi centimeters.
Oh, wow.
8 is 36 times 3 times 12 inches. 9 is counting numbers.
That same whole number?
10, 5 inches. 11, 50. 12 is 32 inches. 13 is 10 plus 2 pi inches. 14 is 3.
Oh, this row.
Hold on.
Okay.
15 is 10 and 5/8. 16 is 3/4. 17 is 54 over 11. 18 is 0.0005. 19 is 4 and 5/8. And 20 is 4.5 feet. Are there any answers anyone wants me to repeat? Raise your hand or write into the live chat. Any answers anyone
I
wants me
have
to
a question. On 13, I put 4 pi over 2 plus 10. Or sorry, 10 plus 4 pi.
Yeah, 4 pi over 2 simplifies to 2 pi.
Okay.
Yes.
8 and 9.
8 was 36 times 3 times 12 inches, and 9 is counting numbers.
Can you say number 6 again?
Number 6 was 14 pi inches. I don't know. I didn't do the arithmetic. Just leave pi in there.
43.96.
That sounds about right. 43.96.
Yeah, I didn't
Yeah.
realize.
Just leave pi in there. Yes. Yeah. For this class, you can always leave pi in your answer. Don't bother multiplying by 3.14 or 22 over 7, because that's just arithmetic practice, which hopefully you don't need. Okay. Are there any questions anyone wants to go over? Any ones that you got wrong and you don't understand why you got an incorrect answer? Again, if you're watching the live stream, hopefully there's somebody out there. I know I've got a few guys who are supposed to be watching these. Right into the live stream. Yeah, but you're here today.
8 and 3.
I don't know that there's anybody
I get
watching.
my phone full of
Why would you watch the live stream when you're here in the classroom?
Because it's
I just realized
convenient.
that. Never mind.
Okay, all right, good. So, any ones that you want to go over?
8.
Number 8, all right, so 8. We have 36 yards, and we're converting it to inches. Unit conversion is always good to go over. All right, now, they say use 2 unit multipliers. We can't go directly from yards to inches. We could, if you happen to know how many inches are in a yard. But let's use 2 like they said. So we're going to go from yards to what?
Feet.
To feet, and then from feet to inches. All right, we'll take 2 steps. Anytime we do a unit conversion, what's the first step? How do we rewrite our starting information? As a fraction. So what will we write 36 yards as? How will we rewrite that?
36 yards.
Over 1, right. 36 yards over 1. All right. Now what we're going to do is what?
Multiply
Multiply
by
multiply by 1. We want to keep the value. So whatever this is that we're multiplying by needs to be equal to 1. And it's going to be a fraction. How do we have fractions that are equal to 1? Right, the top and the bottom are equal to each other. Now, how do we know what's going to go where on this fraction? Whenever we're doing unit conversions,
you need like the other one, like 1 unit on the bottom.
we're going to have a unit on the bottom and a unit on the top. Which one's going to go on the bottom? We're going from yard to feet here. Where are yards going to go?
1 yard at the denominator,
Right, why in the denominator?
so you can cancel it out.
Right, we're trying to get rid of yards. We're trying to get rid of yards and go to feet. So since we have yards on the top of this fraction, we want to get rid of it by having yards on the bottom of this fraction. So these yards will cancel out. Now to make it balanced, we're changing to feet. You always have what you're changing to on top. How many feet go to 1 yard? 3 feet. All right. That's going to get rid of yards and turn it into feet. We'll do similar thing again to change it from feet to inches. Now this time, what are we getting rid of? Feet. So where on this fraction are feet going to go? On the bottom, because they're on the top here, so we'll cancel that by putting it on the bottom. And what are we trying to go to? Inches. So inches will go on the top. How many inches go to how many feet? 12 inches in 1 foot. Notice this is equal to 1 and this is equal to 1.
Mm-hmm.
So we're not changing the value of our original distance. We're just changing the units. Let's go and cancel our units. Yards on the top, cancel out by yards on the bottom. Feet on the top, cancel out by feet on the bottom. If you do this right, all the units should cancel out except for what you're trying to end up with. And we're trying to end up with inches, and we have inches left. So that's a good sign. Now we've got 3 fractions that we're multiplying together. How do we multiply fractions? Multiply across. So across the top, we get 36 times 3 times 12. And what about on the bottom? What do we get?
1.
1. So we could write this over 1, but we can just leave that out, because anything over 1 is just the same thing. And what is this? 36 times 3 times 12, what? Dollars?
Inches.
Inches. Okay. There's your answer. Good habit to get into if you don't have it already is writing a box around your answer to make it clear to yourself and to me when I grade things where your answer is.
For the answer, do we have to multiply?
No. So for these type of problems, these unit conversions, you don't need to multiply them out. Again, that's just an arithmetic question. What I want to see is that you can set this up correctly. And sometimes you'll have things on the top and things on the bottom, and it'll get really complicated. Don't bother multiplying that out. You can just leave it like that. Okay, other ones that anyone wants to go over?
Yeah.
Okay?
Wait, actually,
Yep.
yeah. Number 4.
Number 4. What name is given to polygons whose sides all have the same length?
Isn't that just like a square or a triangle?
So notice when we talk about polygons, we mean any kind of shape that has, well, what is a polygon? Not any shape.
As long as it's closed.
It's got to be closed. Yes. What else does it have to have? No curves. It's got to have all straight sides. That's a polygon. All straight sides, and it's closed. So A square is a polygon. A triangle is also a polygon. A pentagon is a polygon. We've got lots of different polygons. There's a general term that we can use for when all the sides are the same length, for any polygon, no matter how many sides it has. And that's what? Give you a hint. You guys can look at your notes, your textbooks and stuff. That's fine. You don't have to. Starts with an E. This is a term you should be familiar with. Equilateral. From the Latin aequum, meaning equal, and latus, lateris, meaning side. So the latter part means side, the equi part means equal, and the al means it's that sort of thing. So it's an equal side thing. That's all that means. That's what equilateral means. Equal side thing. What's the other term that we know that starts with equi?
Equiangular.
Equiangular. What does that mean? What's an equiangular polygon?
A square or a triangle.
It could be a square, it could be a triangle, it could be any kind of polygon. It could be an octagon, it could be a nonagon, it could be a dodecagon. As long as all the angles are equal, then it's equiangular. Look like a stop sign. Each one of these angles is equal. I mean, obviously my drawing here is not perfect. This is a regular octagon. What do we mean when we say that a polygon is regular?
That's normal form.
There's a more technical definition to it, though. A regular polygon.
It doesn't have like it doesn't like curve in.
It's not concave. It's equilateral. Oh, it's both. And equiangular means regular.
Oh.
Okay. Now, the being equiangular is going to mean that it can't be convex. Remember, a convex polygon has a sort of hole in it, like this guy, where we could take a journey between 2 points that goes outside of it.
Mm-hmm.
Notice this guy is definitely not equiangular. Look, this angle is like a right angle here. We've got this extremely obtuse angle here. We've got an acute angle up here. This is nowhere near equiangular.
Yeah.
If it's equiangular, it's going to have to be convex like this, which means not concave. What's that?
Actually, not even a polygon.
This is the polygon.
Look at how it curves.
Where? This side? Yeah, that's my bad drawing. It's supposed to be straight. There you go. Now it's a polygon. In fact, say 1, 2, 3, 4, 5, 6. It's a hexagon. It has 6 sides. It's not a regular hexagon. The sides are different lengths and the angles are different. It's not equiangular or equilateral,
Yes.
but it is a hexagon.
So a rectangle is not a regular.
A rectangle, you could have a regular rectangle. What do we mean when we talk about a rectangle?
It has two parallel lines. No, two sets of parallel
More than that. So, we'll talk about rectangles first. Rectangles have what? How many sides do they have? 4. What do we call 4-sided polygons? Quadrilateral. So it's a quadrilateral, but it also has what feature?
Only two sides are the same. The other 2 sides are the same.
Okay, but look at the name rectangle. The definition of a rectangle has to do with the angles. What are all the angles in a rectangle?
Right.
They're all right angles. They're all the same. So an equiangular quadrilateral. That's how we define a rectangle. It's a quadrilateral, a 4-sided shape that has all the angles the same. And with a 4-sided shape, the angles have to all add up to 360 degrees. So if they're all the same, they're each 90 degrees. So all angles. Don't be afraid to take notes.
We already have all this down.
That's fine. I'm just giving an invitation. Yes.
Once you're done there,
Go ahead. Okay. Be careful though. Someone said rectangles have 2 sets of parallel sides. That's true, But not all things that have two sets of parallel sides are rectangles. For example, look at this shape. This shape, it's a quadrilateral, it has four sides. These two are parallel, right? If you keep continuing those, they're never going to meet. And these two are also parallel. If you continue those forever, they're never going to meet. But this is definitely not a rectangle. There are no right angles in this. What do we call this guy?
Parallelogram.
A parallelogram, which, so obviously it's got parallel in the name. And the gram part means something that you draw or write. So it's a shape that has parallel sides. Rectangles are always parallelograms, but not all parallelograms are rectangles. Right? You can think of this like a series of circles. So you've got, quadrilaterals out here, and then some quadrilaterals are equilateral. Let's see. This is going to get really complicated really fast. Anyway, squares are a type of rectangle. Rectangles are a type of parallelogram. Parallelograms are a type of quadrilateral. What do we call, so an equiangular quadrilateral is called a rectangle. What do we call an equilateral quadrilateral? Quadrilateral where all four sides are the same length. Anyone? A square is one type of these, but notice we could have this shape. This has four equal sides, but it's definitely not a square.
Oh, I know. Rhombus?
A rhombus, yes.
Yeah.
Every square is also a rhombus, but not every rhombus is a square. For example, this rhombus is not a square. A square is equiangular and equilateral and has four sides. A square is a regular quadrilateral, we could say. All right. Other questions about anything from this test or from the first four lessons? Next week, we're going to have our first actual test on lessons 1 through 4. It'll cover the same material as this test. Number 9.
Natural numbers.
Yes, natural numbers, also known as counting numbers. What are other ways we could describe this? There are other possible answers to this question. Whole numbers, usually we're going to include 0. Pi is above 0.
Whole numbers above 0.
Whole numbers above 0. So you could say whole numbers above 0. You could say positive whole numbers. You could say positive integers is probably the best other definition. Positive integers. An integer is any number that doesn't have a fraction or a decimal in it, including negative ones and 0. So positive integer. Later on, we're going to learn a thing called, we're going to talk about sets. And so the way that we can talk about the set of natural numbers is going to look like that. 1, 2, 3, and then it goes on forever after that. Okay. So later on, we'll talk about it that way. There are a few different answers though. You could say counting numbers. You could say positive whole numbers, positive integers, whole numbers greater than 0. Any of those would be fine. Other questions about any of these? You guys felt pretty comfortable with the ones involving perimeter? 18? All right. 18, we've got division of decimals. I'm going to erase this unit conversion problem. So for 18, they give us 6.432 divided by 1.2864. Now, written like that, it's going to be hard for us to solve that. So I'm going to write it like a long division problem. So 6.432 will go inside, and then outside we'll put 28 0.664. It's always important to copy correctly. Now, when we're dividing by a decimal, that's a really awkward thing to do. Dividing by a decimal. So let's get rid of the decimal that we're dividing by. How are we going to do that?
Moving this.
Move the decimal points. How many places am I going to move the decimal point and in which direction?
At least 4 to the right.
Yeah, 4 to the right. Yeah, I moved 4 places to the right.
If you moved that 4 places to the right, you add a 0.
Yes, I have to move this one the same number of places to the right. Why?
Because if you don't do that, then it wouldn't be equal. You won't be able to.
Exactly. Otherwise, we're changing the value. This is like a fraction. Remember, division is the same thing as a fraction. What I've done here is I've taken my fraction and I've done the same thing to the top and the bottom, so the value stays the same. I multiplied them each by 10,000. Multiplied by 10 brings it over 100, 1,000, 10,000. So I multiply them both by 10,000, and now I no longer have, you know what, I made a mistake in my answer. See what I did wrong in my answer. My apologies to the guys watching. Because it was a total rookie mistake.
Rookie.
This is my second year teaching this class, so. All right, so we've got now 64,320 divided by 12,864. Okay, does 12,864 go into 6?
At least once.
12,864 times what gives us 6? We can't do that. Does 12,864 go into 64?
No.
Does it go into 643?
No.
Does it go into 6,432? It's still that's still smaller than this. What about does it go into 64,320?
Yes, you did.
Yes, it's going to go in there at least once. Okay, about how many times do you think it's going to go in? Let's take a guess.
Twice.
Twice. Well, look at the numbers. We've got 64 and change thousand. And we've got 12 and change thousand. It's probably more than 2. 4 times. Let's take a guess here. Okay, so let's see what's going to happen when we do 12,864 times 4. All right, so 4 times 4 is 16. Carry the 1. 4 times 6, 24. Plus 1 is 25. Carry the 2.
All you gotta do is 4.
So we've got 51,456, which is definitely in the right area there, but it's actually significantly smaller than this. Do you think that's the biggest number of times that this is going to be able to go in? Let's try up one more. Let's try times 5. 12,864 times 5. 5 times 4 is 20. 6 times 5 is 30, plus 2. 5 times 8 is 40, plus 3. 5 times 2 is 10, plus 4. 5 times 1 is 5, plus 1. It goes in 5 times exactly. Now, so the answer is 5. My mistake that I did was I forgot the fact that I had moved this decimal point over, and I just brought this decimal point straight up. Don't do that, in the words of Arnold in Terminator 3. You guys seen that movie?
No.
They're in the mausoleum because Sarah Connor's just died, and the Terminator shows up, and John Connor shoots him in the face, and then the Terminator spits out the bullet from between his teeth, and he says, "Don't do that." Anyway, don't do that. That's what I did. That's why I got that answer that was too small. The answer is 5, because I moved my decimal point over here. I should have thought about my answer.
Unacceptable.
It's true. It shouldn't happen. Because I should have, here's what should have occurred to me. And you should be paying attention for this kind of stuff on your tests and your homework. What should have occurred to me was, wait, you're saying that 1.2864 goes into 6.432 less than 1 time? That's what my answer, 0.0005, means. That it doesn't even go in 1 time. But 1.2864 is smaller than the first number, so it's got to go in at least once. My answer has to be greater than 1. That should have been a dead giveaway that my answer was Wrong.
Wait, so why if you were to do it on a calculator, right?
Uh-huh.
Why can you get some super whack numbers?
I don't know, maybe you plugged it in backwards?
Is it 5 or is
It is 5, yes, it is 5. Another hint here with these kind of problems, when Saxon gives you division problems with all of these weird numbers, it's usually going to be some kind of easy answer like this. Okay, that's just a hint there. Was there another question? I see hand up? Oh, I'm sorry about that. You can move them to a different shelf. Okay. For a question like 13, your answer there you can leave pi in it. So we had that. Erase this here. We have this shape here, where what is 3 on top and 4 on the left side? Is that right?
Mm-hmm.
Yeah, and our units are inches. Okay, the radius here is 2. So for our perimeter, we're going to add together these 3 straight sides. So 4 plus 3 plus 3. And we'll add together this guy here, which is half a circle. So it's going to be 2 pi r divided by 2. That'll be the length. All right, radius is 2, so 2 pi. You can leave it like this. Just leave pi in there. Notice we can't combine 10 and 2 pi, because those are not the same thing. 2 pi, that's somewhere between 6 and 7. 6.28, yeah. Approximately. So you can't combine these any further, but you can leave your answer just like that. All right. Last call for questions about the test, the pre-test, practice test, whatever.
What is it?
The test will be next week, probably Wednesday or so. All right. There's one guy who needs a book, and then we're going to start lesson. I'll get you your book, and we're going to start lesson 5. So open up your textbooks to page number 23. 23.
Are you still live streaming?
I know. I want these guys to be able to see. Don't want them to miss out.
Oh, Jared.
Oh, that'd be such a shame. I missed it.
All right, so lesson 5. Sets, absolute value, and addition of signed numbers. So some of this stuff should be old hat. Some of it might be fairly new. All right, so first thing up, sets. I actually gave you this notation before, but I'll explain a bit more in detail. When we talk about numbers, we can in some ways treat them like things, in that we can talk about groups of numbers. So for example, if I want to talk about the possible numbers of dollars in my pocket, it's not going to be very large. No very large numbers are possible. A negative number is not possible, but there are a lot of different numbers in between that could be possible. A whole long list of numbers that are possible for that. There's a group of numbers, or the technical term we use is a set. A set of numbers means just a group of numbers that we're talking about. And we can give groups of numbers names. So for example, when we write this, A equals, and we use the curly brackets for sets, 1, 2, 3, 4, 5. This means that when we talk about A, that's the name of this set of this group, we're only talking about the numbers 1, 2, 3, 4, and 5, just those numbers. Like for example, if I were talking about the set of students in the class, right? I could have students equals, and then I could have your various names listed. John, Bob, Chuck, etc. Right? If those were your actual names. And I put it in brackets to indicate I'm not doing anything to these numbers. I'm not adding them together. I'm not multiplying them. I'm just talking about them. This is a list of numbers that I'm talking about. And here's my name for it. I'll call this S, this set S, for students. within the set, the order doesn't actually matter. 5 is part of set A, no matter what. The order of them doesn't actually matter, but sometimes we can use certain ways of writing them to indicate things. Okay, so there are different ways that we can write these groups of numbers we talked about. So we were talking about natural numbers. Natural numbers. Instead of giving definitions like positive integer or whole number greater than 0 or a counting number, we can write these as a set. What's the smallest natural number? 1. What comes next? Comes after 1. 2. What comes next?
3.
Now how long does this go on for?
Infinite.
Forever. Convenient way to write that is we just go dot, 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 and that means it goes on forever. All right. This is how we write those as a set. The natural numbers are 1, 2, 3, and so on. So the infinity sign is going to stand in for like the quantity infinity. The dot, dot, dot means keep doing this until I tell you to stop. And since there's nothing after it telling us to stop, we just keep going forever. You could have something like this. This would be a different set. Or here's a different way to write set A. That same set. 1, 2, dot, 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 5. We start with 1, we go to 2, and then we keep following that same pattern until we get to 5. These are the same thing. Here with this guy, there's no stopping point, so we just keep going forever. Okay. So we've got the natural numbers. They start with 1, and then they go on. The whole numbers, there are also symbols for these groups of numbers. Maybe I'll introduce those later. When we talk about whole numbers, anyone remember what the set of whole numbers is? I said it earlier in class. Somebody mentioned this term. Whole numbers starts with what?
Above 0.
Nope.
0.
Starts with 0. So natural numbers or counting numbers start with 1. Whole numbers is the same thing except that we add 0 in. 0 counts as a whole number, but not a natural number. What numbers could we add into this next? Maybe we get things that are less than 0. If we want to include negative numbers also, watch the way that we write this. So we've got 3 dots at the beginning because it goes forever in that direction. -3, -2, -1, 0, 1, 2, 3, and then we keep going forever in that direction also. What do we call this set of numbers? That includes 0, positive numbers without decimals or fractions, and negative numbers without decimals or fractions. Integers, yes, which comes from the Latin word that means whole. These are called integers. So, we already introduced counting numbers or natural numbers. You should know what whole numbers are, you should know what integers are, and you should know how to write them as sets. All 3 of these. Know how to write them as sets. Okay, we'll talk more about sets as the year goes on. Introduce different things we can do with sets. All right. Next up, I'll erase these examples up here. What's absolute value?
Positive number.
Absolute value is always positive. It's always positive because the absolute value means distance on the number line from 0 in either direction. So if we think about our number line, we've got 0 in the middle, we've got 1, we've got 2, we've got 3, we've got 4. We've got -1, we've got -2, we've got -3, we've got -4. 2, how far is 2 from 0? 2. What about -2? How far do we have to go to get between these two? Doesn't matter the direction for absolute value. To get between these two, it's the same distance. This distance from -2 to 0 is the same as the distance from 0 to 2. That's what we mean when we're talking about absolute value. In practical terms, absolute value means if it's negative, make it positive. If it's positive, keep it the same. How do we write absolute value? Oh, also, what's the absolute? Yeah. How do we write absolute value? Well, there's a symbol we can use that means take this quantity and give me the absolute value of it.
Brackets on the side?
Yeah, they're called types. Yes.
Yeah, that's
So. That same example I was giving, we could write like this, or we could even write like this. The absolute value of something means take whatever's inside these pipes, in between the two of them, and if it's not already positive, make it positive.
what are they called?
Pipes. The absolute value of +2 is 2. The absolute value of -2 is 2. One last thing to be aware of. What's the absolute value of 0? 0, because its distance from itself is nothing. All right, that's absolute value. It's a convenient thing. Yeah. Question? Okay. All right, last topic. Good, we're gonna finish. One of the things that we're gonna deal with in this class a lot is negative numbers.
No.
Yeah, unfortunately. So we need to understand how to work with negative numbers. So today we're going to talk about just addition of signed numbers. We're going to talk about signed numbers. I mean, combination of positives and negatives. It's helpful for this to remember what we mean when we're talking about positive numbers and negative numbers. So if I wanted to do something, let's say I want to add 2 and -3. You might know off the top of your head what the answer is. But we can also think of it visually. So let's look at our number line here. We've got 0 in the middle. We've got positive integers to the right, negative integers to the left. Where is 2 on this number line? If I wanted to graph 2 on this number line, what would I do? Put a dot right here on 2, right on the line. Okay. When I add -3 to it, what do I do then? I go backwards. If I were adding a positive, I'd go forwards. If I were adding +3, that means I would go forward 3. So I go 1, 2, 3, and I get to 5. But when I'm adding a negative, negatives will move me in the opposite direction. When we add signed numbers together, positive numbers will move us to the right, and negative numbers will move us to the left. Yeah, my hands are backwards. To the left, to the left. Okay, anyway, so if we're at 2, and then we add -3, where are we going to end up? -1. 1, 2, 3 in that direction, we end up at -1. Let's look at another example. What about if we have -4 plus 2? Where are we starting? How do I graph -4 on here? And just put a dot on -4. Okay, and then I'm adding 2. What do? I go up 2, and I end up at -2. The thing to remember when adding signed numbers is that we're actually, in a sense, doing what? Not addition. We do what? Yeah, really it's more like subtraction. There are three possible situations we can deal with here. I'll just run through each of them quickly. If we've got two positive numbers that we want to add together, what do we do? How do we do 2 plus 4?
No, I,
Yeah, we add them together, and our answer is going to be what? Positive or negative? Answer is positive. If we've got two negative numbers, what do we do? So we have negative 2 plus negative 4. Yeah, our answer is going to be negative, but we still just add the absolute values together. All right, so let me write these examples here. So 2 plus 4 is 6. Negative 2 plus negative 4 is negative 6. We're still adding the 2 and the 4 together, and since they're both negative, our answer is also negative. The third situation is what? So we had 2 positives, 2 negatives.
One positive.
One positive and one negative. What do we do in that case? Things like 2 plus negative 3, negative 4 plus 2. Instead of adding, we subtract. Take negative 4 plus 2, we're not adding 4 and 2 and getting 6. We're doing 4 minus 2, and we get 2. Now, how do we know that our answer is negative here? Think about it. If we're starting out,
Because maybe for the bigger one.
it's further from 0. Yes. 2, adding 2 is not enough to take us from negative 4 back above 0. It just doesn't get us far enough. Similarly, if we had 7 plus negative 3, negative 3 is not big enough, or is not enough of a change to get us back below 0. So the answer depends on which has the larger what?
Like number.
The larger absolute value. Whichever one is farther from 0, that one's going to win out. Negative 4 plus 2. The negative 4 wins out because that's farther from 0. 2 plus negative 3. 2 and negative 3. Negative 3 wins out because it's farther from 0. Okay? So, 2 positives we add, answers positive. 2 negatives, add, answers negative. 1 positive, 1 negative. Subtract, and the answer depends on which has a larger absolute value. All right, let me give out the sheets for problem set 5. I'm going to give you guys a subset of the problems to do. It's not going to be every problem in the set.
Oh, more.
Yes, subset.